diagonal of U, that must be 1. Okay, other than that, it follows the normal procedure of LU. Okay, step number 1, you need to have A equals LU. Step number 2, LY equals B. And step number 3, X equals Y. Okay, so please remember those 3 things. Okay, you need to record. Alright, so now we are going to discuss ni method yang keberapa ni? 5. Okay, the 5th one in this chapter, Thomas algorithm. Okay, Thomas algorithm. So in most reference book, okay, in the textbook, normally before we start with the Thomas algorithm, we have Thomas method. Okay, so before this, in the previous syllabus, you have the Thomas method, okay, in the syllabus, but no more. Few years recently lah, okay, kita dah buang Thomas method. So we only discuss the Thomas algorithm. Okay, so the Thomas algorithm is actually the simplified version in terms of the process. Okay, so the Thomas method is actually consists of all those three steps. Okay, you have the A equals LU, you have LY equals B, and you also have UX equals Y. Okay, the same process. But then when you have a very large system, okay, you normally solve by computer program. You construct your own codes. Okay, so by the Thomas algorithm, okay, the process, all the steps, the 3 steps are summarized into what we call the algorithm, so that it is easier for us to construct our codes. Okay, so we'll see it one by one, the algorithm. Okay, you have 7 here, 7 algorithms. Okay, but don't worry. Okay, basically these 7 formulas, okay, will be given in the list of formula. Okay, no need to worry, no need to memorize each one of them, but you should know how it works. Okay, given the formula, if you don't know how it works, how to use the formula, then no use lah. Okay, so kita discuss hari ni how to apply all this algorithm, okay, in our manual calculation. Okay, but if we are talking about computer program, constructing codes, okay, programming language, so these 7 formulas, okay, need to be written. Dia senang lah, dia akan jadi senang, okay, because you just write the codes for these 7 formulas, and then you just put your system, the coefficient of your A and also your B, okay, and then the program should compute automatically for you. Okay, but for discussion the class, kita solve manually lah, okay, by using these 7 formulas. Okay, before we go to the formula, before we go to the algorithm, let us highlight first, okay, the specific criteria for the Thomas algorithm. Okay, so the criteria is here. A must be tridiagonal matrix. Okay, so you need to remember, before this you have Doolittle, specific criteria for Doolittle, specific criteria for crowd. Okay, now you have one more, specific criteria for Thomas algorithm. A, okay, matrix A must be tridiagonal. Okay, tridiagonal matrix, meaning that you have non-zero elements at the main diagonal. Okay, remarked as D dekat sini, D1, D2 up to the Dn. Okay, you have non-zero elements at the upper diagonal, denote as E dekat situ. Okay, and you have non-zero elements below the main diagonal. Okay, remarked as C2, C3 up to the Cn. Okay, so if you look at the notation, D start with a D1 because you have the elements at row number 1. So we start with D1. Okay, for row number 2 you have D2, so on so forth until Dn. Okay, and for E, for the upper diagonal, you start with the E1. Okay, the same justification because you have the element at the first row. Okay, but you can see it is only up to Em, not En. Okay, because it is if you have a 4x4 system, for example, then your E is only up to row number 3. Okay, so if it's not EN, the last one, the notation is EM. Okay, and for the C, it starts with C2 because you don't have C at row number 1. You have C at row number 2. So that's why we use the notation C2 instead of C1. Okay, so we need to understand this because later we are going to use that notation in the calculation. Okay, so you should know for C, for example, there's no C1. Okay, so at the position of C1, we just put dash. Okay, I mean you don't have the element on that. And for the E, okay, when it comes to the E, you don't have the EN. Okay, so that's on the notation. So again, A must be tridiagonal matrix. Okay, so at the first place, you need to check. Okay, if the question asks for Thomas algorithm, so first thing is to check whether A is tridiagonal or not. Okay, if it is not, first you need to try to rearrange first. Try to rearrange, meaning that we want to see whether it is possible or not for us to swap rows here and there. Okay, to make sure A becomes the tridiagonal matrix. Okay, so the rule is first you look whether A is tridiagonal or not. If it is not, then try to rearrange. Okay, if you can get the tridiagonal, then you can proceed with the Thomas algorithm. If you cannot get the tridiagonal matrix, okay, after you try to swap here and there, you still cannot form the tridiagonal, meaning that you cannot use the Thomas algorithm. Okay, you opt to other methods. Okay, you go to the Doolittle. In fact, you can go to the Gauss elimination. Okay, so I hope you're clear on that. The criteria, the specific criteria for Thomas algorithm, that is A must be tridiagonal. Okay, but at the first place, sometimes the trick in the problem, okay, it is stated the given matrix is not tridiagonal at the first place. But okay, after you try to rearrange, okay, swap the rows here and there, you can come out with a tridiagonal. Okay, so tipsnya, if the question asks for Thomas, dia mesti akan dapat tridiagonal lah. Okay, if you end up dengan the system cannot it cannot form a tridiagonal matrix, then you need to check back. Okay, but in the exercise, in the tutorial, can happen. Okay, but in the test, in the exam, normally if the question asks for the Thomas algorithm, somehow okay the tridiagonal can be formed. Okay, otherwise there's no use for us to ask you okay about the Thomas algorithm. Okay, all right, and the formula I'm not going to discuss in detail, just apply the method directly. Okay, so you have 7 over there. So basically, if we refer to the previous discussion, 1 up to 3 basically refers to step number 1 in your Doolittle and also the crowd. Okay, more or less, okay, step 1, A equals LU. Okay, and then step 2, this is forward substitution. This is more or less is Ly equals B, and the last 2 is Ux equals Y. Okay, basically that we can assume like that. Okay, 3 steps altogether. All right. So what I suggest you in the exam, in the test, you form this table so that it is easier for you to put all the values. Okay, you look at the list of formula. In the list of formula, it is given in the form of the point form like this, 1, 2, 3, and so on. Okay, but I would suggest, okay, on your paper, you form this kind of table. Okay, so that it is easier this way. Okay, and it is easier for me to mark as well. Okay, itu yang pentingnya. Alright, so I'm going to go straight to the example 12 to illustrate the process. Okay, so given the system, 4x4 system here, so first of all, you need to question, is this tridiagonal? Yes or no? So you might want to extract your coefficient first, then it will be clear to you whether A is tridiagonal or not. So if I take out the matrix A, which is your coefficient matrix, then at the first equation, you don't have x1, you don't have x2. So meaning that it is 0x1, 0x2 lah. Okay, 3, 4. Okay, and then you have 2, you have 9, you have 1, 0. Okay, and then you have 0 as 1, 1, 9, 4, 2, 1, 0, 0. Okay, so you need to check the main diagonal, the upper diagonal, lower diagonal. Other than those three, there should be 0 elements, which is not in this case. Okay, so we can say that initially it is not. Okay, initially it is not here, meaning it is not tridiagonal. Okay, so ask further, can we rearrange? Yes, Hazim.
Sorry.
No problem. Tak apa, selingan. It's okay. Ada yang ngantuk-ngantuk tu, I can understand. Alright. So for this case, initially it is not. Okay, but then we need to try to rearrange first. Okay, so jangan terus, okay, cannot. Then cannot you use the Thomas. Okay, not like that. So you need to try to rearrange first. Okay, so rearrange your rows, okay, in the matrix, okay, in matrix A, so that it becomes the tridiagonal. Okay, so tridiagonal, at the first row you have A11, you should have A12. Okay, so we can see from the row that we have here, so it's either row number 2 or row number 4 should be at the top. Okay, and then we look. Okay, the second element is 1, the second element is 9. Okay, third element at the first row should be 0. Okay, so yeah, inverse row 4 and 1, swap. Okay, swap 4 and 1. So you need to have 2, 1, 0, 0. Okay, betul. And then in the second row, okay, we should have the element. Okay, in the second row, the first element should be there. Okay, second element should be there. The third element also should be there. Okay, so the rows that satisfies those conditions is 2, 9, 1, 0. So mungkin for the first time, it is quite hard for you just to look macam tu saja untuk letakkan. So you might want to jot down. Okay, try on the paper. And then we have 0, 1, 9, 4. So itu tak berubah. And then we have 0, 0, 3, and 4. Okay, so that you can check. The main diagonal should be non-zero elements. The upper diagonal, non-zero element. Lower diagonal, non-zero element. Other than that, they are all 0. Okay, so now you have the tridiagonal now. Okay, but don't forget. So ini just remark on your notes. Okay, dalam exam tak perlulah nak tulis benda-benda ni. Okay, but don't forget, when you change or when you swap A, you need to remember B also need to be swapped. Okay, sebab it comes with an equation kan. Okay, so when you swap the rows, don't forget B also need to be swapped, meaning that your B also change accordingly. Okay, the effect of B, okay, later will be seen in the next process, in the next discussion. Okay, so your B is supposed to be, okay, so related or the corresponding B for the first row is 9 lah. Okay, so you look for 2110 2100. So the B, okay, is 9. Okay, and then change accordingly. Second row is 6, third row is 8 and 8. Okay, so that is your B. Okay, now we can have our table. So form a table just like what you have in the previous page. Okay. Get your ruler, have nice column, and so this is I. So just put formula, 7 formula altogether. So 1, 2, 3, 4 here, referring to the system that we have, dimension. Okay, so we have 4 by 4 system, meaning that we want to solve for x1, x2, x3, x4. Okay, so put the column for 1, 2, 3, 4. Okay, so here, so this is for the I. So at the top, I referring to the subscript. Okay, and this is the formula. Okay, so the first formula that you have, okay, you can refer to the first one is di. Okay, so di. Next is ei. Ci, bi. Okay, that's the first one. Okay, at the first place, based on the given question, okay, so you should be able to fill in up to these 4 rows. Okay, D, E, C, B. Okay, because if you refer just now, the main diagonal denote as D. Okay, upper diagonal is E, lower diagonal is C, and B is the right hand side value of your system. Okay, so 4 rows should be able to be filled. Okay, and then we have the alpha. Okay, so the formula for the alpha, we have 2 formula for the alpha. The first one is alpha 1, which is D1, not DI, D1. And then the rest of the alpha should follow this formula. I minus 1. Careful with the subscript. Okay, you have 2 things. And then we have the beta I. Okay, so beta I, the formula is ei over alpha I. Okay, and then we have omega. Oh, you can assume W lah, senang. Okay, omega 1 equals B1 over alpha 1. Okay, that one is specific for omega 1 only. The rest of the omega follows the formula on this one. Okay, this one. B minus Ci and so on. Okay, so just write the formula. So Bi minus Ci omega I minus 1 over alpha I. Okay, and lastly our x. Okay, x n. Okay, n is your dimension of your system. Okay, so we have 4 by 4, so n is actually 4. So you have x4 over that equals to omega n, so omega 4 lah. Okay, other than that, it should follow this formula, xi equals omega I minus beta I xi plus 1. Alright, okay, so now, so first from that table, okay, now we want to copy, okay, copy the corresponding D, E, C and B. Okay, so at the main diagonal, so look at the after you have rearranged lah. Okay, so jangan tengok yang asal. Okay, so your main diagonal is 2, 9, 9 and 4. Okay, so itu dia the main diagonal. E is the upper diagonal, so we start with E1. Okay, we have 1, 1, 4, 0. C is the lower diagonal, but lower diagonal start with C2 Okay, so tadi I explain we don't have the first element on the row 2 kita ada. Okay, so you don't have C1 tak ada. Okay, so we start with the C2, so we have 2, 1 and 3. Okay, lower diagonal. B is the right hand side value of your system. Okay, so we have 9, 6, 8, 8. Okay, so itu. Alright. Now, we move to the alpha.
Doktor,
Alpha, yes.
EI untuk yang 4 tu dash juga ke? Ataupun letak kosong?
Oh, dash. Sepatutnya dash. But anyway, in the process, you tak akan involve pun with that. Okay, tapi okay, so sepatutnya kita letak dash lah. Alright, thank you for that. Okay. And then, okay, now alpha. Okay, you have two formulas for the alpha, but specific for alpha 1, it is D1. Okay, so kita tengok alpha 1, so this column dekat sini, okay, the elements here should be for alpha 1. Okay, so alpha 1 equals D1, so you look at D1. D1 is 2, so straight away you put 2 here. Okay, because it is D1. Okay, and in this column, so this column is actually for alpha 2. Alpha 2 should follow this formula. Okay, follows that formula. Meaning that for the alpha 2, if I can put here, so alpha 2 is actually D2 minus C2 beta 1. Okay, beta I minus 1. So your current I is 2, so you have beta 1. Okay, so you can see you need to have the beta value first before you can compute the alpha. You don't have the beta yet. Okay, meaning that before you can proceed with the alpha 2, you need to go down here. You need to get the beta 1 first. Okay, because in the formula, you need to use beta 1. Okay, what is beta 1? So look at the formula for beta 1. So beta 1 is E1 over alpha 1. So you have value for E1. You have value for alpha 1. So it is possible for us to get the beta 1. Okay, so E is 1. Alpha is 2. So 1 over 2. So I put in decimal. So 0.5. Okay, only then you can go back to your alpha 2. So it means the working process, you go down first to the beta, then you go up back to the alpha. Okay, so now alpha 2 follows this formula lah. So D2 is okay because we have D2 which is 9. Minus C2, C2 is 2 here. Beta 1 is 0.5. Okay, you have just computed the beta 1. Okay, so put the value formula here and there. Okay, so you come out with the alpha 2 which is 8 in this case. Okay, so the same process, okay, when you want to get the alpha 3, so the formula for alpha 3 is D3 minus C3 beta 2, which is, okay, you don't have the beta 2 yet, so you need to go down. So here's the process, zigzag macam tu. Okay, so you go down, you go up, you go down and then you go up. Okay, so macam tu. And then you go down lagi. Okay, so with that process or working steps dekat situ, we can have beta 2. So I just put here. So when you do revision, make sure you can get the same value as mine here. Okay, so 0.125. Then when you go up to the alpha, so it should be 8.875. Okay, then go down, you have 0.4507. Okay, and finally you get 2.6479. Okay, And then for the beta, you don't have to compute the beta 4 because it's no use. You don't need the beta 4 in any of the formula in Thomas algorithm. Okay, so basically you just put dash over there. Okay, so beta is only used in the formula of alpha. Okay, so when you want to compute alpha 4, you are going to use beta 3 saja. Okay, so up to beta 3 saja. So you don't need to compute the beta 4. Okay. In fact, we don't have dekat sini so we don't have the E4, so we cannot get the beta 4. Okay, so that's on the alpha and beta. So they're working together. Okay, in order to get the alpha, you need to compute the beta first. Okay, so you go down and up, down and up. Okay, like that. Okay, clear on alpha and beta. Now, we move to the W. Saya panggil W lah senang. Okay, omega ni susah nak sebut. Okay, W. W1, okay, the same as alpha. For W1, it has its own specific formula. Okay, for the W1. See, can you hear the knocking on the door? Aduh, hai lah. Sabar eh. Sekejap. Aduh, hai. W. Okay, so W is B1 over alpha 1. Okay, so W1 is B1, so B1 is 9, okay, over alpha 1 is 2. Okay, so you may want to jot down, okay, how do you get W1 at the first place, okay, so that when you do revision, you know where the values comes from, okay. Saya just sebut saja. W1 is B1 over alpha 1, okay, B1 is 9 here, alpha 1 is 2. So 9 over 2. So in decimal, so I can put 4.5. Alright. And W2 follows the formula that we have put there. So W2, so saya letak dekat situ. So W2 equals B2 minus C2 W1. Okay, so you need the information from previous W. Okay, over alpha 2. So B2 is 6, C2 is 2, okay, W1 is 4.5, alpha 2 is 8. Okay, so just careful when you refers to the values, okay, so make sure you refer to the correct one. Alright, and then with that formula, we come out with our W2 negative 0.375. Okay, so on so forth for W3 and also W4. So 0.9437 and then 1.9521. Okay, so that's on W. Okay, now the last part is X. Okay, so the intention, our main intention is to have the X values dekat sini. Okay, but before we can get the X, okay, so you have to go through all the process lah, finding the alpha, beta, W, and finally the X. Okay, so you have also two formula for the X, okay, but the first one is given X4, okay, X4 equals W4, meaning that you start from the back, okay, so this is backward substitution in the LU, okay, if you refer to the Doolittle, so ini step yang last kali, okay, you do the backward substitution, you get your X4 first, okay, so X4 is W4, X4 first, which is W4. So you just copy 1.95 to 1. Okay, W4. So you start from the last one. Okay, and then when you want to compute so this is the working process. You go, okay, you start with the X4 and then you go to the X3. Okay, so X3 follows this formula, which is W3 minus beta 3 X4. Okay, so in order to compute the X3, you need the values from X4. Okay, so that's why we start from the last one first, so X4. Okay, so with that formula, so substitute here and there. Okay, the W3 is 0.9437, beta 3 is 0.4507, okay, and X4 is 1.95, so on. Okay, so with that formula, we have 0.0639. Okay, and then you go to X2, so you have negative 0.3830. And finally, you get X1, which is 4.6915. Okay, so that's all on the Thomas algorithm. Okay, boleh faham tak? Clear lah. It's just how do you implement in terms of formula saja. Just plug in the value in the formula. Okay, and the formula is given. Okay, no need to memorize. Okay, ada soalan tak on Thomas algorithm? It is not quite popular to be asked in the exam sebab dia tak challenge pun kan. Just masukkan formula, just write down the formula and fit in accordingly. Okay, if you so the key there is DECB tu. Okay, if at the first place you put the correct values, then insyaAllah the rest will follows accordingly. Okay, cuma you need to know how it works lah. Okay, which one that you need to start first, mana yang need to go down first. Okay, macam tu saja in terms of the process. Okay, other than that, I think it should be fine. Okay, senang untuk di macam tak perlu nak faham sangat pun. Okay, you just know how to use the formula saja. Okay, but in the first place, we need to check whether A is tridiagonal or not. Okay, so Thomas ni useful when it comes to computer program lah. Okay, when you want to construct the coding. Okay, if you have the algorithm, it is easier for you to write your codes. Okay, in terms of manual calculation, macam ni lah je. Rupanya gayanya. Right? Okay, so if you can understand that, how it works, okay, try on your own on example 13. Maybe, I think can be done less than 10 minutes, maybe. Yeah, try example 13. Have your table. First, need to check whether this one is tridiagonal or not. Okay, so just have a table dulu. So first thing is to check whether this one is tridiagonal or not. Okay, if it is not, then try to rearrange. Okay, so that it becomes tridiagonal. If it is already tridiagonal matrix, then just follow, just proceed with the table. Okay, follow with the E, D, E, C, B, and so on. Okay, so try dulu. So after this, after 10 minutes, I'll pick few of you, yes, some of you to share the answers. Okay, so buat dulu. Okay, saya buat Google Sheet dulu so that nanti you can fill in the answers dekat situ. Okay, buat dulu. Each rows yang kita ada dekat situ lah, fill in what are the elements of the D, E, C, B, alpha, beta, omega, and finally the X. So 8 people. I'm going to spin the wheels here. So ada 8 orang. So bismillah. So the first one, tadi your section ni. Okay. Okay, nampak tu Imran. Imran Hakimi on D DI. So put every elements on D. Okay, D1, D2, D3, D4. Okay, Imran D. Next. Kalau ada tidur tu cepat call kejutkan. Hah? Imran tak ada? Dia ada appointment dekat klinik. Okay, kita remove. Imran tak jadi. Okay, no problem. Okay, on D, still on D. Okay, Rahim. Muhammad Rahim. Rahim ada? Do we have Rahim underline?
Ada.
Ada. Alhamdulillah. So Rahim D Rahim isi tempat D. So boleh je terus letak. Tak perlu tunggu saya view kat sini. Alright. E. Okay, so atas tu senang je, just copy je kan. Okay. E. Johan. Johan ada Johan? Johan, are you there? Johan? Ada tak Johan? Tengok sikit. Ini 60 students. 60 suppose ada lah. Johan. Apa? Tu ada Johan. Tolong isi. Johan C. CI. Siapa tu? Izzat. Ya, Izzat Idris. Izzat on C Okay, Izzat B. B senang je. B. Izamuddin. Okay, Izamuddin.
Yes, doktor.
Yes, please write down for the B. Okay. B, and then alpha. So alpha, a bit of calculation involved. Tak nak. Ibu tengah kerja. Sorry, ada selingan. Okay, alpha, Hafiz, Syazani. Alright, Hafiz on the alpha. Hafiz Syazani. And then beta. Okay, beta. Okay, Nurul Afika. Do we have Nurul Afika? Ada tak Afika? Nurul Afika on beta. W or omega. W. Syahira. Amira Syahira. Boleh. Okay, Amira Syahira on W. Yeah. Boleh. Aduh, hai. Last one is on the X. X. Naim. Okay, Naim on the X. Okay, those 8 people. Okay, please write down the answers. Okay, so we are done with that. Okay, alright. So D, E, C, B. Itu senang lah. Okay, alpha. Alpha tadi Hafiz. All right, please come back. Okay, we'll proceed with next method, which is Cholesky. So Cholesky asks in the test, in the exam, okay, because few things can be asked in the Cholesky rather than just that simple Doolittle and crowd. Okay, compared to those two, this one will be more interesting. Okay, to be asked. Okay, banyak benda sikit boleh ditanya. Alright, so for the Cholesky, the specific criteria. So please highlight the criteria for Cholesky is A must be what we call symmetric positive definite. Symmetric positive definite. In short, I can have SPD, symmetric positive definite. Okay, SPD matrix. Okay, as the name implies, okay, so symmetric. So A must be a symmetry matrix. Okay, so first of all, okay, symmetry. Okay, meaning that the elements on the lower part should be equal to the elements at the upper part. Okay, so the opposite elements, okay, so you cross the diagonal and then the elements opposite the diagonal too should be the same. All right, so that is symmetry matrix. Okay, so first of all, it is symmetry, and A need to be positive definite. Okay, so before we can proceed with the Cholesky method, we need to make sure A is an SPD matrix. Okay, symmetric positive definite. Okay, so there are two ways of showing or verify whether A is an SPD or not. Okay, so first by definition, second one by the theorem. Okay, so by definition, a symmetric matrix A is positive definite if you can show X, T for the transpose, X transpose multiply with the A, matrix A, and multiply with the X. Okay, should be zero, should be greater than zero, should be positive, should be always positive for any X, vector X not equal to zero. Okay. So, but by definition, it is quite difficult to show, okay, because the X that we are talking here is the unknowns. Okay, so your XT, X transpose is X1, X2, X3. You multiply with the A. A is a known matrix somehow, but you multiply with the unknowns, vector X. Okay, X transpose, okay, multiply with the A, okay, and then need to multiply one more time with the vector X. Okay, so your expression will be in terms of x1, x2, x3. There could be positive, there could be negative here and there. So you will see in terms of addition or subtraction. And then that will make it quite hard to show whether it's going to be always positive or not. Okay, because you don't have the value. Okay, you don't have a single value. Okay, but then instead you have expression in terms of x, okay, in terms of x1, x2, x3. Okay, so by definition, it is quite hard to show A is an SPD metric. Okay. But alternatively, we have another option, which is by using the theorem. Okay, so a symmetric matrix A is positive definite if the following properties are satisfied. Okay, so first, A must be non-singular matrix. What it means by non-singular is the determinant of A must not equal to zero. Okay, so this one can be done by the calculator. Okay, so make sure you know how to get determinant by using the calculator. Okay, as long as it is not 0, then A is called the non-singular matrix. So that's criteria number 1. Okay, criteria number 2, the diagonal elements are positive. Okay, this one is very easy to see. The diagonal elements, okay, meaning that your A11, A22, A33, A44, if we have 4 by 4 system lah. Okay, so it is clear, okay, by your matrix A. Okay, so the diagonal elements must be always positive. You cannot have negative value, okay, in your diagonal elements. Okay, so number 2. Number 3, the maximum of AKJ, the absolute of AKJ. AKJ referring to the elements of your A, of your matrix A, except for the diagonal. Okay, because for the diagonal, it is denoted by AII. Okay, so max AKJ dekat sini referring to the elements other than the diagonal. Okay, so the maximum should be less or equals to the maximum of the elements of the diagonal. Okay, so maksudnya dekat sini. Nantilah, okay, I explain number 3 here when it comes to the example nanti. Alright. Number 4, AIJ square must be less than AII times AJJ. Okay, I cannot be J. When I is J, it means that it is elements of the diagonal. Okay, so we don't test on the elements of the diagonal, we test on elements other than diagonal. Okay, so for every elements that you have in your matrix A, okay, except for the diagonal, you need to check whether your AIJ square satisfies this equation here. Must be less than AII times AJJ. Okay, for example, for elements A12, for example, A12, okay, you need to check, is it A12 square less than A11 times A22? Okay, so if you do not satisfy this condition, meaning that you don't have SPD matrix. Okay, so in order to say that your matrix A is an SPD matrix, it needs to satisfy all of these 4 criteria. Okay, if one of the criteria is not fulfilled, meaning that you can straight away conclude A is not an SPD. Okay, so dia mesti semua sekali mesti satisfies all those 4. Okay, and then once you have confirmed on that, meaning that if you have A is an SPD matrix, then you can proceed with the Cholesky method. Okay, Cholesky method follows the general procedure of LU. Okay, general procedure means at the first step you have A equals LU. Second step, you have Ly equals B, and third step, you have Ux equals Y. Okay, the same process in the Doolittle and also in the crowd. Okay, but okay, there's one more specific criteria for Cholesky. Okay, so that's why saya cakap tadi, Cholesky is more interesting to be asked. Okay, please highlight this one, the second one. U equals LT. Okay, the U is the upper triangular matrix, is equal to the transpose, okay, transpose of L. Okay, maksudnya dekat sini, if your L is written, okay, using this form A, B, C, D, E, F, G, H, I, J dekat sini, then U is the transpose of your L. Okay, the row in the L must be column in the U. Okay, so they transpose. U equals LT. Okay, so 2 things lah for the Cholesky. First, A must be SPD matrix, right? Symmetric, positive, definite. And then when it comes to the calculation, we must make sure we write our U as the transpose of L. Okay, other than that, it follows the 3 steps of the LU method. Okay, now let us see example 14. Just to check on the A, okay? First, okay, check on the A first. Show that matrix A for the following linear system is symmetric, positive, definite. Only then we proceed with the Cholesky. Okay, so write down our A Okay, extract your A from the system. So A is 6, 8, 4, 10, 14, 6, 14, 45, and 8. Okay, first, we need to check. Okay, first, A must be symmetric lah. Okay, because the name is symmetric positive definite. So first of all, A need to be symmetry. Is A symmetry? Yes or no? Is A symmetry? Yes, is it? Is A symmetry?
Yes, doctor.
Not quite. If it is symmetry, then the elements at the 10 here, elements at that position must be the same. Okay, so they're opposite. Opposite element tu dia mesti sama. 4 and 14 should be the same. 6 and 45 should be the same. Okay, so this one, okay, initially it is not symmetry. Okay, not symmetry. So what do we need to do? We need to rearrange if possible. Okay, if it is not possible, then cannot use the Cholesky. Okay, so rearrange. Okay, try to rearrange so that your A at least symmetry first. Only then we can think of positive definite pula. Okay, so you can see you have 14 two times, you have 6, okay, 2 times. Try to rearrange. You have 8 here and there. Okay, so those are the elements that you need to look for. Okay, yang mana ada value dia ada 2 kali. Okay, and then try to rearrange the rows, swap here and there, so that you can come up with a symmetry. Okay. So yang hanya ada sekali je, you ada 4, 10, okay, and then 45. So most likely that would be your diagonal lah. Okay, and just try to rearrange. Okay, so for this one, I just put the answer directly here. So 4, 6, 8, and then you have 6, and then 10, and then 14, 8, 14, and 45. Okay, so again, maybe for first time, it is not quite obvious lah to see. Okay, but then when you do a lot of exercise, it will come naturally to you. Okay, then you just can rearrange dalam kepala je. Okay, but for the first time, maybe you want to try on the paper. Okay, kalau silap boleh padam and so on. Right? So but be careful. Okay, because this is also quite a common mistake lah. When the student change the A, meaning that when they do the swapping, they forgot to change the B. Okay, when you swap the rows, okay, so meaning that your system here, okay, your B values need to be changed accordingly because it come out with a B. Okay, they package this together. Okay, the equation at the left hand side comes with the right value at the right hand side. So B need to be changed as well. Okay, so 4, 6, 8 at the first row. So B dia yang pertama adalah 2 lah. Okay, and then 6, 10, 14. So the corresponding B should be 4 and then 11. Okay, so you might want to highlight that part. Okay, B tu especially. Okay, kadang-kadang terlepas pandang. Alright. Okay, so now you have symmetry now. Okay, A is symmetry, and then we proceed with the proof A is positive definite lah. Positive definite. Okay, so dia mesti symmetry dulu, baru you boleh proceed with the positive definite. Okay, so criteria number 1. So I'm using the theorem. So 1, the determinant of A. Okay, so you put all the elements of your A in your calculator. So you will have the determinant of A equals to 100, this one. Okay, so this one, as long as it is not 0, then should be fine. Okay, so we satisfy the first one. Okay, but you cannot just stop yet. Okay, because this is just number one baru. Okay, so you need to proceed with criteria number 2. Okay, criteria number 2 says the elements, the main diagonal, the elements of the main diagonal should be always positive. Okay, so refer to the previous page. AII must be greater than 0, always positive. So if we look at our A, after we have rearranged, so our A11 is 4, which is positive, clearly. A22 is 10, okay, also positive. A33 is 45, also positive. So we satisfy the second criteria. Third criteria, the maximum. So ini yang saya not explain in detail just now. So I just put this one first. Max, okay, must be less or equals to the max. Okay, now I want you to see at the right side first. Okay, so you tengok dekat sini dulu. Look at the right side dekat sini. Max in the criteria dekat sini. So at the right it says the absolute of AII. Okay, AII referring to the diagonal A11, A22, A33. So we put the elements of the diagonal 4, 10, 45. Okay, dekat situ. Alright. And then on the left side, you put elements other than the diagonal. Selain daripada diagonal, you put that element. You put those elements at the left side. Okay. So other than diagonal, you can see we have 6. Okay, ada 2 times of 6, so you can just write once. Okay. 6, you have 8, you have 14. Okay, because you have symmetry kan, symmetry. So basically you can just look either at the lower part ataupun upper part saja. Okay, because you are repeating basically. So other than diagonal, we have 6, okay, and then we have 8, 14. Okay, so now in criteria 3 here, you see at the left hand side, okay, between 6, 8 and 14, okay, which one is the maximum? The largest value, okay, at the left hand side is 14. Okay, so basically we are questioning this. Is this fulfilled or not? Okay, you are questioning that. Okay, is it true that the maximum of 6, 8, 14 okay, less or equals to the maximum of 4, 10 and 45? Okay, so at the left side, the maximum value is 14. Okay, at the right hand side, the maximum out of those three, okay, 4, 10 and 45. So the largest would be 45. Okay, so you can check 14 is less than 45, so this one is fulfilled. The second one also fulfilled. Okay, faham eh? Number 3. Okay, it's okay if you don't write in terms of notation K, J, I, not really need to do that. Okay, you just can come up with the figures terus, okay, with the values. You write max 6, 8, 14, okay, less or equals to the max 4, 10, 45. Okay, so you satisfies that one. Last one, number 4, AIJ square must be less than AII times AJJ. Betul lah. Okay, so this one. Alright, so I cannot be J, syarat dia. Okay, the rules say I cannot be J, meaning that you are not testing for the main diagonal. Okay, you are testing for if we have 3 by 3, then we are testing for A12. Okay, is it A12 square less than, okay, A11, A22? Okay, we are checking that. So refer to the matrix A. A12 dekat mana? A12 is 6. Okay, row number 1, column number 2. So we have 6 square, which is 36. Okay, must be less than A11. A11 is 4 times A22 is 10. Okay, so we satisfy this lah. Okay, 36 is less than 40. Okay, so satisfy that. But you need to check for every single elements that you have in your A. Okay, because sometimes the last one tu yang tak satisfy. Okay, so jangan gembira dulu, jangan happy dulu. Okay, so you need to test for every element. Okay, but since you have symmetry matrix, meaning that if you are checking for A12, it's supposed to be the same as checking for A21. Okay, so you don't need to check 2 times lah. So you can write, so this one is equal to A21. So sama je. Okay, sebab dia symmetry. Okay, so if you look A21, it's supposed to be less than A22 times A11. So sama je, A11 times A22. Okay, so lagi kita ada A13. A13 square, is it less than A11 times A33? Okay, then it's supposed to be sama dengan checking for A31 square. So A13 is 8. Kat sini row 1, column 3. So 8 must be 8 square. Is it less than A11 is 4, A33 is 45. So 45 times 4, times 4. Okay, so suppose satisfy this one. Okay, so 64 less than, I don't know, 45 times 4. Okay, so you can have the value from your calculator. Lastly, we check for A23. Okay, because we don't check for the diagonal, meaning that we don't check for A11, no, A22, no, A33 also, okay, we don't check for A33. So A23 square is equal to A32, okay. So we are checking, is it less than A22 times A33. So A23, row 2, column 3, so 14 square is less than 10 times 45. Okay, so have a value from your calculator. So need to, so for this one, it satisfies the condition. All right, so you can write all conditions. Okay, satisfied. Okay, so therefore A is an SPD matrix. Symmetric positive definite. And SPD matrix. Okay, or A is a symmetric positive definite. Okay, boleh faham ni? 4 criteria for the Cholesky. So you need to show all of them. Okay, so tak boleh skip satu. Okay, in fact, for criteria number 4, you need to check every elements on in the matrix A. Okay, so that is the first task. Okay, to prove A is symmetric, positive, definite. Okay, once we have confirmed A is an SPD matrix, only then we can proceed with the Cholesky. Okay, therefore we proceed with the Cholesky method. Okay, proceed with the calculation. Okay, so step 1. Okay, step 1, A equals LU. Okay, but don't forget for the Cholesky, okay, matrix U equals to the transpose of L. Ini specific for Cholesky saja. Okay, so please highlight that one. Meaning that, okay, so A, so write down your A. So 4, 6, 8, 6, 10, 14, 8, 14, and 45. Okay. Okay, so A yang latest lah, bukan the asal dari soalan. Okay, A with the SPD. Okay, matrix L, A equals LU. So L, the normal definition of L lah. Okay, so lower triangular matrix meaning that the lower part should be non-zero elements. So we can have A, B, C, D, E, F. Okay, nak guna PQR pun boleh, tak ada masalah. So 0, 0, 0. Okay, no specific criteria for the L, meaning you need to write the general form of L. Okay, U somehow must be L transpose. Okay, so the rows in L must be column in U. So A 0 0, B C 0, D E F. Okay, dia terbalik je. Alright, so now multiplication of two matrices at the right hand side. Okay lagi tu? Ada dah snooze land.
Okey, doktor.
Okay. 14:45. Okay. At the left hand side. Okay, at the right hand side, multiplication of two matrices, row 1 times column 1. So we have A square, J, okay, the first element. Okay, A square plus 0 plus 0. Second element on the first row, A times B plus 0 plus 0 juga. Okay, so we have A, B je. So put some space kat situ because in the next row you have more terms. Okay. A, B, and third element on the first row is AD plus 0 plus 0. So AD. Okay. Second row. Okay, so second row times first column. So AB plus 0 plus 0. So you have AB over here. And then B square plus C square. And then BD plus CE plus 0. Lastly, third row, first column, AD, and then BD plus CE. Lastly, D square plus E square plus F square. Okay, that's your right hand side matrix. Okay, now the same as the process in the Doolittle, okay, as well as the crowd, we are comparing both sides. Okay, so compare left hand side and right hand side. Okay, element by element, position by position. Okay, so first of all, we can get the A. Okay, but so by looking at the right hand side, we know that A square equals 4. So we can have A. So A is the square root of 4. It is actually positive negative 2. Okay, but common practice, we take the positive. So I remark here, maybe when you do the division, you might have this question. Okay, why not? We take the negative value. Just to state here, common practice is to take positive one, positive square root. Positive square root. Okay, but you can have the negative. Okay, you're gonna have negative 2, but then your next value, your B, your C, your D must follow, okay, based on the negative value itu tadi lah. Okay, so you tak boleh nak buat, oh bila nak kira B nanti, you nak consider A is positive. Tak boleh pula macam tu lah. Okay, so if you want to take the negative value, then the rest of the calculation must follow, okay, based on A yang negative. Okay, but then the common practice is to take positive value lah. I think we are more comfortable on the positive value rather than negative. Okay, kita tak suka kan yang dengan negatif-negatif ni, kita suka yang positif je. So common practice is to take the positive value. Okay, but if someone asks you, can I have the negative value? Then jawapan dia boleh. You can have negative value. Okay, next we can have the AB. Okay, so you can see elements at the right hand side ni pun, okay, supposed to be symmetry. Okay, because at the first place it is a symmetry matrix. So you see you have AB somewhere here. So in the opposite, okay, element it is also AB. Okay, so AB equals 6. Since we we know our A, we can get the B. So B is 6 over 2, so B is 3. Okay, next we can get the AD. So AD equals 8, so we can get the D. D is 8 over A, so 4. Okay, so on so forth. B square plus C square equals 10. Okay, kat sini. Okay, this is what I've mentioned just now. If you take A equals -2, for example, then of course your B value is going to be negative. Okay, so when it comes to the calculation of C square here, okay, but then you have the B square. Okay, even though you have negative value somewhere here, then when you compute the C, you are going to square juga pun, okay, the B tu. Okay, so B square plus C square equals 10. So cut the story short here, C equals 1. Okay, because your B is 3, so 10 minus 6 is 4. So the square root, is it? B square. Okay, betul lah 9. Okay, 9. 10 minus 9 is 1. Okay, so the square root of 1 is 1. So C. Next, we can get, okay, we can get, so just put somewhere here, we have BD. Okay, BD plus CE equals, so at the left hand side it is 14. Okay, 14. We have B value, D value, C value, so we can get the E. So E equals, so substitute the value here and there, the known value, masukkan dalam calculator, okay, plus minus here and there, so you can come up with your E, which is 2 in this case. And lastly, D square plus E square plus F square equals 45. Okay, so masukkan D, masukkan E, you come up with your F, which is 5 in this case. Okay, alright. So in the exam, in the test, you might have numbers in terms of decimal pun kat sini. Okay, so you need to expect that jugalah, okay, in the exam, in the test. So step 2, alright, so we have Ly equals B. Okay, what is L? So look back at your L. So this is L. A, B, C, D, F is your L. Then you put all the values that you have obtained in the first place, in the first step. So A is 2, di sini 0, 0, B, C 3, 1, 0, A, B, C, D. D is 4, E 2, F is 5. Okay, that is your L. Alright, and the temporary variables, so put y1, y2, y3. Okay, B is the right hand side value from your system. Okay, but don't forget B is this one, okay, the one after that you have swapped, not the original problem, because this is not SPD. Okay, after you rearrange, okay, it is symmetry now. So B, the correct B is supposed to be 2, 4 and 11. Okay, so kadang-kadang ini jadi mistake, common mistake. Okay, 2, 4 and 11. Okay, so now you have 3 simultaneous equations that you can solve by your calculator. So I can write by calculator. Okay, or basically you can see directly 2y1 equals 2. So y1, of course, 1. Okay, so by calculator, I can write my y, vector y, which consists of y1, y2, y3 lah. So for this one, it is 1, 1, 1. Okay, and then step last kali, step 3. Cepat, nak tidur dah ni. Ux equals y. Okay, step 3. Okay, so U in the Cholesky is the transpose of L. Okay, the transpose of L. So you can look at step number 2. Rows becomes column. Okay, columns becomes row. So 2, 3, 4, 0, 1, 2, 0, 0, 5. That is U. X is your x1, x2, x3. Okay, so put the y. Y from the second step is 1, 1, 1. So again, therefore, by calculator one more time. Okay, so write down your vector x, or you can write one by one. X1 equals, x2 equals, x3 equals. Okay, so by the calculator, so basically, if you use manual calculation, you come up with the x3 first, because on the third row you can see it is 5x3 equals 1, so x3 equals 1 over 5. So basically kalau manual kita start daripada belakang. Okay, 1 over 5, and then you go up to the second row, you have 3 over 5, okay, equivalent to decimal number. So if you use in terms of decimal lah. Okay, so negative 4 over 5. Right? So that's how you use Cholesky to solve the three simultaneous equations kat sini. Okay, to solve a system. Okay, ada soalan tak? Cholesky. Ada soalan?
No, doctor.
Okay. Alright, so I repeat one more time. Okay, the condition. Okay, condition for the Cholesky, it must be, first of all, must be symmetry. Okay, kadang-kadang dalam soalan, mistake dia, student tak tunjukkan simetri tu. Okay, prove that A is symmetric, positive, definite. So first, Zuhimi tanya apa? Sekejap. Oh, kalau, okay, alright. Kalau ada soalan kat Telegram, boleh. Okay, saya highlight sikit kat sini, example 15 ni. So yang pertama tu, prove that A is symmetry, positive, definite. So first kali, you must check ini dulu, symmetric dulu. Ini yang pertama. Okay, maksudnya you have 5 lah sebenarnya. Okay, satu, dia kena simetri. Okay, simetri atau symmetric. Yang kedua baru you sambung dengan 4 kriteria tu. So sebenarnya ada 5 lah. Okay, so sini determinant, dekat sini A, I must be greater than 0. Okay, so sebenarnya ada 5. So common mistake-nya yang nombor 1 tu, simetri tu tak tunjuk. Okay. Diagonal must be positive. Lepas tu you have maximum of A, K, J must be less or equal to the maximum of A, I. And lastly your A, I, J ke dia pakai? J. Square must be less than A, A, J, J. Okay, so itu. Okay, kadang tertinggal ni. Okay, kena tunjuk dia simetri. Oh, if it's already symmetry, you just state saja. Okay, A is symmetry. Okay, macam tu. And then number 2, you check determinant and so on. Right? So itu. Number 1, kriteria pertama, A must be symmetric, positive, definite. And then during the calculation, you must remember, matrix U is the transpose of L. Okay, so itu 2 things on the Cholesky. Okay, the process, the 3 steps follows accordingly lah untuk LU. Okay, process for the LU method. Okay, sama macam do little, sama macam crop. Okay, maybe I can put answer here so that you can check later. The answer, basically you can have the answer from your calculator at the first place. So this is -2, 3 and 5. Okay, so make sure you get that. Tak ada soalan? Tak ada. Okay, later if you have questions, immediately you can ask me. WhatsApp ke Telegram, no problem. Okay, tak ada? Tak ada soalan? Chatting? Okay, alright. So I think we can stop here. I'm going to share the attendance once you have scanned and